Hi everyone. So at this point we've covered ionic bonds and covalent bonds, and now we're going to lastly get into our final type of bonding called a metallic bond. So the metallic bond is going to help us address the question basically why metals have the properties that they do. Okay. So the metallic bond is a little different than types of bonds we've seen so far. So when we talked about a metal, um, rather than having a whole bunch of neutral atoms kind of like bunched up together, so it's like how we would have for like most other material. Okay, the metals are actually in the form of cations, and these cations are actually pretty much held closer together. Now, cations are all positively charged. We know that two positive charges are going to want to repel each other. So then how exactly do these positive charges stay near each other enough to be tightly packed and be hard like a metal is? Well, the valence electrons of metals actually are able to move around and they're very free flowing. So we've already kind of talked about the transition metals, how their valence electrons are a little bit weird. Um, it's got a lot to do with the energy in their d orbitals, the fact that the noble gas configuration is a little out of reach for them. So the valence electrons of metals are actually able to move around like pretty freely. So metallic bonds are essentially the attraction between the cations and all of these different valence electrons moving around. So these valence electrons are thought to be in like a sea of electrons, where it's the whole ocean of electrons, and these cations are just kind of swimming in there. And the fact that everything's kind of free flowing and everything's in motion, it actually helps to increase the attraction between the cations and the electrons, and so everything can actually get held together. The attraction between the cations and these free-flowing valence electrons is referred to as the metallic bond. So the metallic bond is a little bit different than the type of bonds that we've been talking about. Rather than talking about holding specifically two or more elements together and for forming like a physical like tether to them, it's more just these cations are held together by different electrons that are just kind of like flowing around and just keeping them there. So you can take a look here how we have all these different electrons. They're not really tethered to one atom, but rather they're just kind of out there in an open space. And then these metal cations are just kind of like hanging around in there, but they're still pretty much closely packed because of that electron um, and cation attraction to each other. So we've talked about some properties of metals in the past. For example, they're great conductors and they're very ductile and malleable. So the reason why metals are good conductors is because for something to be a good conductor, electrical current has to be able to move pretty freely through it. Well, these electrons are free flowing, meaning that there's a lot of space between them, but not enough space if they're like too far apart. So because these electrons are actually like constantly moving around and they're flowing, that actually helps promote the electrical current to run through them. So because of the fact that these electrons are pretty much free flowing and spread out, that actually helps metals become conductive. So it helps them pass this electrical current through them because the electrons are able to move. We're going to learn all about how conductivity is actually just a result of the ability of these electrons to kind of move around a little bit more. Additionally, metals are ductile and malleable, meaning they can basically bend without break. They're not very brittle. Okay, they can be drawn into wire. Basically, metals are tough. Okay, they're not tough that they're just gonna like break up. And this is because of the fact that these cations are able to kind of like move past one another rather than just being held closer together. So because they're able to move around, because of the fact that there's these electrons, these cations don't actually repel each other, but rather they just kind of slide past one another. These electrons help to essentially insulate the cations from one another. So because the cations are able to move around each other rather than just um, push each other apart, that lack of repulsion due to the insulation of the electrons helps make the metals actually like malleable and tough because of the fact that there's no repulsion. So the electrons are actually very responsible for the properties that we see for these metals. Now the last thing we're going to get to here, well, we know of some metals that aren't exactly on the periodic table, like steel. and bronze, and brass. So these are all metals that we're familiar with, and yet we don't really see them on the periodic table. Well then, how exactly do they exist if they're not actual elements? Well, they are something called alloys. So an alloy is when you have a mixture of elements with one of them being a metal. Okay, so when you have different elements combined together and at least one of them is a metal, you have what's called an alloy. An alloy is basically like a hybrid metal. And the point of an alloy is to better the properties of the original element. So basically, you can make metals better by combining them with other elements. For example, sterling silver. Sterling silver is 92.5% silver and 77.5% copper. So it's not pure silver. The reason why we have sterling silver is because by combining it with copper, this silver is actually harder and a lot more durable than pure silver. Similarly, bronze, which is a mixture of copper and tin, is a lot harder than copper, and yet it's easier to work with. So alloys are basically a combination of different elements, with some of them being a metal, to kind of just help out the properties of the original metal. Basically, it helps make them better. So we have alloys here to kind of just make better forms of our metals. There's a lot of alloys used for different things. Just like I mentioned before, the steel, the bronze, the brass. We know some of these from buildings, from instruments, and things like that. And this is because of the fact that their properties are just better, so we have a lot more use for them.